Alright, so now we've talked about graphing it, we've talked about compound interest, we've talked about doing a real world situations with it. So now we're going to go ahead and do the last part, which is transformations. Transformations. Now this one, we've done it already, so I'm going to fly through it because it doesn't take that long to do transformations or go through it. So it's a review. So vertical transformations, going up or down. Alright, so a function that we're going to deal with here is going to be f of x equals b to the x power. And we're going to talk about the changes that happen with it. So, for example here, if we have b to the x and it's a plus c, so it's big, it's not on the same line as x there, it's not the same line, it's big. If we have a plus c on the back, it's going to move up. It's going to go up. And just like before, if it was a minus c on the back or a negative c, it moved down. And again, that is on the back side of it. It's not at the same size as the x. It's not up there. Alright, for number 2, as another refresher, moving it left or right, horizontal, horizontal. We're going to start off with here, and notice on this, the number is with the x. It's up there with the x, so it's an exponent. 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 So if it's up top, remember it goes opposite of what you think. So it means it's going to move left here. Since it's a positive c, it moves left, the opposite of what you think. And if it's negative, it moves right. So remember again, opposite of what you think. Now, the last time I had A, B, C, all this stuff. This time I'm just placing the C in its different spots. And that C is going to tell you whether it goes up or down, left or right, and all that good stuff. So, again, it's about the position. Position is the important part. So here we're going to have a flip or a non-flip. And my original notes, I had the word reflection here. So if you see my original notes and you see reflection, it means the same thing. Reflection means the same thing. All right, and here, I'm only going to show you just one, as there's another flip that happens too, but I'm not going to show you that. So this just flips across the x-axis. And I'll give you an example of that in a few seconds. I'll put that over here on the side. And then this one here just does not flip at all. It doesn't flip. No flip. So it should look the exact same way as it should. So in this part here, just to make sure everybody has it, you know, there's the asymptote there. So then it goes up like this and there's no flip. Now when it comes here, I'm going to go ahead and do the dotted line for the parent graph, and then I'm going to show you the transformation. So this is that parent graph here. Remember, it goes through 0, 0 right there. It was 0, 1, sorry. And again, that went through 0, 1. Remember, that happens for every exponential function unless you do a transformation to it. But if you flip it, that means it's just going to flip across the x-axis, so it's going to flip down. So it looks like that. And this point here is at 0, negative 1. So not bad. We can do that. And I'm going to throw this in here also. If you have a negative here for the exponent, a negative x, that's going to flip across the y-axis. And it kind of looks like what we did for example 2. When we compare example 1 and example 2, it flipped across the y-axis for that. So again, I'm going to show you this part. And also here, if you remember again, to have a positive exponent, you must flip that. It must be flipped. So here, that's over 1. So if we flip it, that means we're going to do 1 over b to the positive x power. So what happens graphically, we have this wonderful graph here. Now again, I'm going to show you the parent graph, which is the dotted one. Again, goes through 0, 1. Right there, 0, 1. But with this one, since it flips across the y-axis, it's going to go this way. Ooh, don't touch the x-axis. And again, remember, asymptotes are there. So it still goes through 0, 1 though. Just make sure you understand that part. It still goes through 0, 1. Alright, and then the last thing is example number 4. Number 4. This is going to be shrink and expand again. And the same exact rules apply. But this time we're going to have a number in front of the b. And so as we did the regression stuff, you saw, and even then when we did the Linda thing, you saw there was like a number here, and then there was a number here, then there was an exponent. So the same thing happens here. But again, if c is greater than 1, it's going to shrink or compress. And if c is between 0 and 1, it's going to expand. Exactly the same thing we said before. And so in examples of these really quickly so you can get an idea of what we're talking about, it's going to look something like this. It's going to look something like that. So if it's going to shrink, it's going to have like a 3 or something like that in front of it. And also it could look like this too. So just to give you a heads up and an idea, it could look like this. All depends on what book you're looking at or what internet source you're looking at. So it could look like either one of those. And again, the top part's for the shrinking part, and this bottom down here is for the expanding. And give you a visual of that too, because I like visuals, and I think you guys do too. Oh. So if we have the original parent graph that comes about here, and again goes through 0, 1, right there. That's your asymptote going on there. When it says it shrinks, that means we're going to have it come this direction. If we say expands, we're going to make it come wider. It makes the solid gray line. So this is expands, it comes wider, but it still goes through 0, 1. So it's not hard. We can do that. Alright, so in the next video, we're going to do an example, just listen to transformations and all that good stuff. So we already know how to do that.